My topic is conversion of galvanometer into voltmeter. Okay. As we know that the voltmeter is always connected in parallel in the circuit. So let us see the galvanometer is connected like this, and one resistance S is connected in series. It is I is the current which is passing through the galvanometer. Okay. So a galvanometer is can be converted into a voltmeter by connecting a high resistance as in series. Okay, high resistance S in, say S is the shunt resistance. Okay, and Ig is the current passing through the shunt resistance as well as galvanometer. Okay, so if this is the required voltage which is to be measured, then S is the shunt resistance, external shunt resistance, which is to be connected with galvanometer in series. Okay, the value of S is high. The one important point is it is high and it is connected in series. These are two important points. Okay, say this point is A and this point is B. Let Z be the resistance of the galvanometer. Okay, S is the shunt resistance. It is having high value. Ig, galvanometer current. Okay, VAB, potential difference between A and B. Mind it, A and B is not connected. It will connect kora hua nai. That is why I am giving dotted line. B is the potential difference between A and B. So Ig current, this Ig current is passing through S as well as V. So therefore, according to Ohm's law, according to Ohm's law, what we get at this point, VAB is equal current. Ig is the current passing through two resistances, Is plus G. Total resistance is S plus G. Okay, so this is the required equation from Ohm's law. So what is our interest? We are now we have to find out S. Ami S will be over. Karan amak jodi koy how you will convert a galvanometer, what will be the value of shunt, what will be the range, then we want to find out S. So from this simple equation, you can very easily find out S. How? So this is the potential, let it be VIB. So VIB is the potential difference between these 2 points. So VAB IZS plus IGG. So we want S. So VAB minus IGG, S is equal VAB by IG minus G. So this is the equation by using which you can easily find out the value of shunt resistance. Okay. So VAB means the maximum potential difference that you can use from this instrument. So when you connect this shunt resistance S, this whole device will be converted into a voltmeter. So then it will not be a galvanometer, it will be a voltmeter, right? As soon as you connect a shunt resistance having high value in series, the galvanometer immediately converts into voltmeter. Okay, and then the 2 points will be connected to measure the potential difference. So let me show you one example how we can solve a problem. Okay. Question: a galvanometer having resistance 10 ohm. It requires suppose 50 milliampere current for full scale deflection. How it can be converted into a voltmeter which can read up to 2.5 volt. Okay, this is your question. So this is the question. First of all, you have to understand what is the question. The question is that you have a galvanometer. Okay, solution. The question is that you have a galvanometer having resistance 10 ohm. Okay, the galvanometer has a resistance 10 ohm, right? The galvanometer, this is a resistance 10 ohm. Okay, so you are to convert this galvanometer into voltmeter. So you are to convert it into voltmeter by connecting this resistance. This will become a voltmeter. According to the question, 10 ohm is okay. This 10 ohm is okay. It requires 50 milliampere current for full scale deflection. Here ইয়াৰ মাজেদি যদি 50 মিলিএম্পিয়াৰ কারেন্ট যায় বহুত কম কারেন্ট তেতিয়াহলে ই ফুল স্কেল ডিফ্লেকশন দিব okay it means that IG galvanometer current is 50 milliampere so you have to convert it into ampere if you multiply it by 10 to the power minus 3 then it will be converted into ampere so 50 milliampere current becomes now ampere right so iman khini current gole ই সম্পূৰ্ণৰূপে ডিফ্লেকশন কৰে so according to the question you are to convert this into a voltmeter so that it can measure a voltage up to 2.5 volt so VAG AB is equal 22.5 volt right so এখিনি ভোল্টেজ জুখিবলৈ হলে এফালেদি কারেন্ট তোমার ম্যাক্সিমাম কারেন্ট 50 মিলিএম্পিয়ার পঠিয়াব লাগিব তাতকৈ বেছি পঠিয়ালে তো নহব হি কাটাডাল পুরা ডিফ্লেকশন দিব কারণ 2.50 মিলিএম্পিয়ার কারেন্ট গলে হি সম্পূর্ণ ডিফ্লেকশন দিয়ে তাতকৈ যদি বেছি কারেন্ট যায় এটো বাধা দিবলৈ হলে এটা শান্ট রেজিস্ট্যান্স লাগিব সো শান্ট রেজিস্ট্যান্স কি করব ইট উইল অপোজ দা মুভমেন্ট অফ কারেন্ট ফ্লো অফ কারেন্ট থ্রু দিস ওয়ে it will allow maximum 50 milliampere current through this right so if you calculate the value of S from this expression then you can easily convert it into a voltmeter okay so you have to find out S okay using this relation you have to find out S very simple so the value of VAB is this the value of IG is this value of Z is this so everything is very simple so each and every value of milliampere is converted into ampere is volt SI unit ohm so you just put and find a value of S okay very simple problem okay you just put the value of VAB is how much VAB is equal 2.5 volt 2.5 okay IG is equal how much 50 into 10 to the power minus 3 right and Z is equal how much Z is equal 10 Z is equal 10 so very simple calculation okay 2.5 into 10 to the power 3 50 minus 10 right so 2.5 into 10 to 1000 okay 50 minus 10 0 0 will be cancelled okay 20 so it will be 50 minus 10 so answer is 40 ohm so 40 ohm is the correct answer so how you will write your answer is by connecting a 40 ohm shunt resistor in series with the galvanometer it can be converted into required voltmeter okay voltmeter so very simple so this is your conclusion you have got the answer as 40 ohm so you have to write that by connecting 40 ohm shunt resistor in series this should be 40 ohm this should be 40 ohm okay so you have to convert this galvanometer into voltmeter then this will be a voltmeter okay so in this way you can convert a galvanometer into voltmeter and if you connect low resistance in parallel it will be ammeter if you connect high resistance in series, then it will be in it will be converted into voltmeter. Okay. So these are the discussions starting from galvanometer. Okay. As you know, the galvanometer, moving coil galvanometer is nothing but a rectangular coil. Okay, placed placed within a magnetic field, right? When current flows through the magnetic through the coil, as we have discussed, that the coil is fixed in a spring, so this produces the north pole and south pole. Cylindrical north pole and south pole produces radial magnetic field. Radial means the cylindrical, the north pole and south pole, just if you observe top side from the top, then it will be circular. So from the top it will be circular. This is the rectangular loop. Okay. So when current flows through this and passes through this, and what will happen? This conductor and this conductor, the vertical conductors, will experience some torque. It will be pushed in the inward direction. This conductor will be pushed in the upward direction, right? So the magnetic field is radial, right? The magnetic field is radial because at all points the plane of the coil is parallel to the lines of force. That is, the angle theta is 0 at all time. When the angle theta is 0, then cos theta is 1. Okay. When cos theta is 1, we have the maximum value here, maximum value of torque. Then this side and this side will not experience any force. Only this vertical side and vertical side will experience opposite force. That is F is equal to ILB. As you remember, F is equal to ILB. From that we have calculated the torque. As we have calculated torque, okay, torque is calculated from this force and distance. As you remember, when we calculated torque, that is the value of torque. The anti-torque is exerted by the spring. Okay, restoring torque is exerted by the spring. So we just compare the restoring torque C theta with the deforming torque tau. From this expression, we found that the current I passing through this is directly proportional to theta. It means that this is a moving coil galvanometer. When current passes through this, the deflection, which is given by a pointer, the pointer is connected with the spring. The pointer shows the deflection. That is, current increases, deflection increases, right? This is a simple principle of a galvanometer. Now, as soon as you connect, okay, as soon as you connect this with a shunt resistance, suppose shunt resistance is this S, okay, then this is positive point, this is negative point, this is negative point, okay, then it will be a voltmeter, okay, then it will become a voltmeter. This is the point. Or otherwise, if you want to convert it into emitter, then you have to connect a shunt resistance S, okay, low value, low resistance. So there's small amount of current passes through this, and some current will pass through this. IG will pass through this. This is galvanometer, and IS will pass through this. Then the whole system will be emitter. A good instrument to emitter হৈ যাব যদিহে তুমি ইয়াত এনেধৰণে কানেকশ্যন কৰা. Okay, so this is all about emitter and voltmeter. So in this talk I explain how a galvanometer is can be converted into a voltmeter. Okay, so I think everything is clear.